This is CIS30A Week 2 Part 4 lecture. In this part of the lecture, I'm going to cover list, tuple, and dictionary. And within lists, we will talk about the common built-in methods and also the common built-in methods for tuples as well. So in this part of the lecture, I want to touch on lists. And we previously saw how string can be represented, or string would be typed as lists, as we would use loops to be able to iterate through the characters in the string. So in Python, a list is equivalent to an array in C++ or Java. And we can have a list that would be empty. We can have a list that would contain integers. We can have a list that would contain mixed data. So as you can see on page 14, a list can contain various data type. So unlike the other languages, we don't have to type it. So in this case, we would have a mixed type. We can also have a nested list, or we would know that as a 2D list. I will come back to this. So what you have is you would use the square bracket to tell the interpreter that this is a list container, and we can have characters in the list. And very much like string, you would be able to use index to access the item in that list, as the first item would be at index 0, and it would sequentially go through the next item. The next element would be the element at index 1 after the 0, and so forth. You can also use negative index to access specific element in that list. So to illustrate this example, here is an example of a list. I have a list and I declare it with the name my list. And in this list, it contains string, or in this case, we only have one letter per string. So I have Python in that list. And if I want to output only the first element, I would use the 0 index to represent the first element. If I want to output the t, this would be index 0 for the p, index 1 for the y, and index t for the index 2 for the t. So when I run this at this particular index, index 4, which is the fifth element, that will be the O here in that list. So here I would output the O. And so therefore you can also use index value to be able to access the element of that in that list using the index value here. The next example is a nested list. So for the nested list, I have a list that's declared as n list, and in this list it's a mixed data type. The first list is a string, so that would be happy, and nested in that list, the second list, another list inside that list would hold integer 2015. And the way that we would index this is we would use the first value here is going to be the list number. So the first list is list 0. And the second value here is going to be the element inside that first list. So if you want to be able to access this, so when we ran this, we wanted to access the A, which is at index 1 of the first list. So first you would have the value for the list number, which is 0, that's the first list, and the element number of that list, so that would be 1, which is A, because 0 is H. For the next print here, from that nested list, N list, I wanted to access the second list, which is the list of numbers, and I wanted to access the fourth element, which is index 3 of that second list, which is number 5. So when I print that, it's going to give me 5 because it is the fourth element of the second list. So the list number always goes first and the element number always goes second inside the square bracket in the nested list, for the nested list. So you can see these examples on page 14 and 15 of your notes. Next, I'm going to touch on negative indexing of lists, very similar to what you've seen in the string when we talked about that in part 1. We can also use negative index value to access specific element of that list. So to bring this to the IDE, we can go to the program. So here is a list called my list. I declare this list as my list, and I would have these strings inside the list, each letter per string. And if I wanted to print out the last element of that list, which is the M, I simply use the -1. So if we go from right to left, we would start with -1, and then we move left, that will be -2, and so forth. Then for the next line, I wanted to print the fifth element from the last, which is going to be 1, 2, 3, 4, 5. So when I run this, it's going to print the last element, which is M, using -1 here. And the next line, it's going to print the O because it's the fifth element from the last. So what it would do is we can use the negative value inside the square bracket to be able to access specific element of the list. And if you use a positive value, then you would go from left to right, starting at 0 as the first element. Next, I'm going to talk about list slicing. Very similar to string slicing, we can use index range to be able to display or access a range of elements inside a list. So I declared a list called my list, and I assigned it these strings inside the list, 1 letter per string. And I wanted to be able to access the elements in range and print them out. So I wanted to start with the third and go to the fifth element, putting the marker on the fifth. So it's going to print the third, the fourth. So when I run this, it's going to print the third, which is O, G, and an R. So we're going to go from 3, 4, and 5. So we would start at 2 and we're going to go to 5. So the colon is used here to indicate that we are using a range of index start and stop inside the square bracket. On the next line, I wanted to print the elements from the beginning to the fourth using the negative index. So I'm going to use the print method, bring down the name of my list, and when I leave this blank here, it automatically defaults to the beginning of the list, and then the colon, and I'm going to go to the -5. Remember, when we're using -5, we're going from right to left, starting with -1 on the last. So at this point, what we're doing here is we are printing the P, and that will be the first letter because it's default to 0 here. And then we would go to the -5. So -1 is here, 2, 3, 4, 5. We put the marker right here. So that would only allow us to print the R. So therefore it's printing the P and the R here. And on the next line, I'm going to print from the 6th element to the end. So I simply do a print method with my list name, and inside the square brace, I would have the 6th element, which is index 5. And the colon is just to note that it's going to be the range. And when I leave this blank, it's just going to go to the end of that list. So it's going to print the A and the M as A is the 5th element, the sixth element, and then to the end, which is the M. So A is the 6th element, and then M is the last one because it's going to go to the end. On the next line, I simply leave them both blank. So it's going to print from the beginning to the end. And we can do it this way, or we can simply print my list like this. And it should be able to print the same as you can see. So if you do it like this, leaving blank with the colon inside the square bracket, or you can simply just pass the list name inside the parameter of the print method, it would still give you the same result as we print from the beginning to the end. And this is an illustration for list slicing, very similar to string slicing. You can find the example on page 15 and 16 of your notes. And it gives you various examples here going into 17. You can also use the plus sign operator to combine the list. So that way you can have 2 lists combined. That's called concatenation, very similar to string. You can use the asterisk operator to repeat the list a number given of times, very similar to the string as you've seen in the part 1 of the lecture. And next, I'm going to talk about the built-in methods for lists. This is important because as you go through the class, you would have programs that will require you to add in specific value in an existing list. So we can use insert, or we can delete or remove specific value. So I'm going to talk about those built-in methods now, starting with insert. So this is page 17 of your notes. And I'm going to bring you to the IDE to show you how that's going to be written in the IDE and ran. So in the example here, we have the insert method. And insert method allows us to insert or put in a value in an existing list. So to start, we have a list called odd. We declare it as the name odd. And we have two values. The lists have to be 2 or more elements. So we have a 1 and a 9 in that list. And they are integers. Then we're going to issue the insert method. So we're using the insert method. And what we want to do is we're going to insert the number 3 in between. So we wanted to insert 3 after 1. So when I ran this, I would have the 3 added here. As you can see, it's going to be 139. Next, I wanted to insert 5, 7 between 1 and 9. So I wanted to add in a number 5 and a 7 between 1 and 9. So with this, what I wanted to do is I wanted to specify the location where I wanted to insert and how many numbers. So I wanted to start because we already have 139 previously, and we wanted to put the 5 in as the third element, so that would be index 2, and we would have 2 numbers inserted there. So we would have a 5 and a 7 inserted after the 3. So as the result, we would have 1, 3, 5, 7, 9. So this is a way that we can use insert. And after we insert it, of course, we should simply print to verify what has been inserted in our list. So next I want to talk about delete and remove, how we would be able to delete a certain element or a certain item from the list. And you can use index to delete one element. You can use a range using index range to delete multiple elements. So let's take a look at that in programming in our IDE. So in this example, I declare my list, and it contains PROBLEM. These are strings, and each string contains one letter. And unlike the other method, you can use delete, DEL, DEL, and then my list. So this allows us to delete an item from the list using its index. So when I run this, and I'll explain why the error is there, it's intentionally placed there. So when I run this, I would see that first I deleted the element at index 2, so 0, 1, 2, so we deleted the O at this point. And when we print it to show, as you can see here, the O has been removed. It has been deleted. Then next we're going to delete a number, multiple items from that list using delete. So del, my list, and then simply put in the range of the indices inside the square bracket. So we would start with index 1, and remember that we already deleted the O previously, and we would go to the index 5. So it's going to get rid of the R, the B, the L, the E, and it's only going to keep the M. So the P and the M is left. And then on the next line, we simply delete the entire list that's left, which is the P and the M. So when we delete, what it does, it takes that allocated space for that container and it gives it back to the system. So when we try to print it again, it's no longer there. So that's why it's going to give me the error in the traceback. So what you see is that once we deleted that container, my list, it no longer exists. Not that it's an empty list. No, it's no longer exists. So when we print it, it would throw an error. So this is what you see using delete. Another way that we can remove a certain item or element from the list, we can use the remove, or we can use the pop method. And we can also clear the method from the empty list. So the pop method removes and returns the last item of the index is not provided. Now that, because the way that we wanted to use pop, first in, last out, it's a good way to clean up our stack when we pop certain element from that container. So here are some examples for using pop and clear and remove. To start, we have a list, and we declare it with the name myList. It contains these strings. We wanted to remove P, which is the first element from that list. Now this is different than delete in that in delete we use index value. In remove we simply just use the string itself or the element itself. So we would have the P remove here. So when we print, we would print the list with the strings that are left after P has been removed. So the output of that, as you can see, we got rid of those. I mean, we got rid of P and we have those. Next, we are going to pop, and if we wanted to pop the index 1 from the updated list, so index 0 now is going to be R, index 1 is going to be O. So when we print that, we print which one we pop, that will be the O. So we pop the O. So the O is gone. So with the pop, you don't have to pop the last element. If you leave it blank, it's going to automatically go to the last element and pop that out. But if you put in an index value, it's going to go to the position of the index and it's going to pop that out. Now, when we print, since we pop O, we would have R, B, L, E, M left, which is what we have here. Next, we're going to print and we're going to pop, and since we leave it blank, it's going to get rid of the M. So M is gone, and we printed that. Next, we are going to clear. We are going to reprint our list with the M is gone, and then we are going to clear our list. So once you clear, what that does is it gets rid of the element inside that list and make it into an empty list. So unlike delete, clear still keeps the container, but it's going to make it an empty container. So it becomes an empty list. So when we print that, it simply gives us the square bracket because it is now an empty list. So that kind of shows you how to use remove, pop, pop without parameter, and clear. So I wanted to touch on append and extend next. We talked about insert, and this is another way that you can add a value into your list without using insert, but we can do append. And append is commonly used, especially when you have a list to start and you would have the user input and store their input into a list. You can use append method to do that as well. So here's an example. I have odd is my list that I declared, and inside that list I have 1, 3, and 5. I'm going to go ahead and add 7 to that list. And so when I run this, append simply add it to the last element in that list. It's just going to drop it after the 5 here. It's going to add it as the last element. So when I print it again, I have 1, 3, 5, 7. 7 is added last. Then I can also use extend, and the way we use extend is when you have multiple elements that you wanted to add to the list, you would use extend. Append only allows you to add one element. Extend allows you to add multiple elements. So if I wanted to add 9, 11, and 13 to the list that I previously had, then I can simply use extend. And when we extend and we printed, we have 1, 3, 5, 7, and then we extend 9, 11, and 13. So altogether, you have an updated list of the 3 elements added, and it simply dropped that as those last 3 there. And that shows you how you can use append and extend. So on page 19, I also included a list of the common methods that you would use for lists outside of what we talked about. We talked about quite a few of these, but we didn't talk about sort, reverse, copy, and there are more, but these are commonly used. So what you see is that you would see them in various application, especially for your project or for your assignments. So make sure that you look through them. And I previously touched on 2D lists again, but I want to revisit and make sure that you understand. On the bottom of page 19, going into 20, it talks about 2-dimensional lists. So basically, it's a list inside another list. So in this example, what you have is you have 2D nums is the list name, and you have a list that encapsulates 2 other lists. And so as you recall, we wanted to first look at the list number. The first list is always going to be index 0 as the first index in that parameter. The second list is going to be index 1. And anything more than 2 dimension, Python documentation recommends that you use dictionary. Now, to access the elements in a list, we would use a for loop. Since it's a nested list, you should use a nested for loop. And so we can write for I in range length of that list, and for j in range length of the list with the index, and we wanted to print I and j, so we wanted to be able to print the 2-dimensional lists as parallel. So to print the first dimension, we have 2, 4, 6, 8, and 10. To print the number 2, we would use 0, 0 as it is the first list and the first index. To print the number 4, we would use 0, 1 because it's the first list and the second element, index 1. We want to print number 6, list 0, first list, and we wanted to print the third element, which is index 2, and so forth, as you can see. Now to go to the second list, we would have list number 1, and if we want to print the 3, that will be the first element. So list number always goes first, element number always go next. And that's how you work with the nested list. So I will bring you to the example in Tawny. So here's my example. So I have these values initialized for the nested list, and you would use a comma as a separator there. So as you notice, we would have the nested for loop to iterates. And just to print the list itself, you can print, because it's nested, we wanted to use a nested for loop. So here, first, we wanted to go ahead and show our nested list. Then, using the nested for loop, we would be able to print our index. The first index is for the list number, and the second index is for the element. So we would be able to print individual element as we loop through for each of our lists. Next, I'm going to talk about tuples, and tuples can be found on page 20 of your notes. So tuple is similar to list. It is a container we can store a group of elements. The big difference between the tuple and the list is that tuple, once it's assigned, it cannot be changed. It's static. So, and the tuple, it doesn't use the square bracket, it uses the parentheses. And you can separate each of the element using comma, very much like the list, but the way we indicate tuple is we would use the parentheses. So once you assign the values into the tuple, you cannot update them. And the way you can update them is you would have to nest the list inside a tuple in order to update those values. So now you can have integers, float, lists, strings, etc. inside a tuple. You can also have mixed data types. So tuple is similar in list that it can contain different types. It's different that it uses parentheses, and once you assign the value, you cannot change those values inside the tuple. If you plan to change, then you should use a list instead of a tuple. You can have multiple lists nested within, that's fine, inside the tuple, and you can update the content within the sublist here. Okay, the subcontainer. So to show this, we would see this here. So I have my tuples, and this is an empty tuple. So when I run this, first it's empty. That's the first part here. I would assign it integers 1, 2, 3 and print it. I can assign it mixed data types and print it. I can also have it mixed data type, and then inside it I would be able to nest the list so it shows that it is a subcontainer within that tuple, like this. I can access the tuple using index for the element. That's shown here too. So very much like the list, you can use index, range of index to print. Now I can nest it in very much like the 2D, two-dimensional list. When I use the nested, I would start with the tuple, which tuple number first. So this is the first tuple and the element. Okay, so that kind of shows you similarities and how with the list and how different it is from the list and how to use tuple. Very much like the list, but you cannot update it unless it's a nested list within a tuple. So next I wanted to show you how we would be able to change the tuple. So here is my tuple, call my tuple. I declare that. I have 4, 2, 3, and inside it I had a nested list 6 and 5, and these are the only two values that I can change. So if I wanted to change this, here I can run this and I can show. So first we print out the tuple. If I wanted to change this, I wanted to update this to 4, 2, 3, 9, and 5. Take out the 6, replace 6 with the 9. I simply state the element, which is the fourth element from the first list, and what is to update. So here what we have is my tuple, the position of that element. Since it's the first list, that would be list 0. Actually, element 0 in that first list. And in the tuple, it's 0, 1, 2, 3. So that will be the index 3 for the position of the tuple, and the element, which is the first element from that list. And I wanted to update it with a 9. So when it print, it's going to give me 4, 2, 3, 9, and 5. Like this. And then another example, my tuple, I reassign it with strings. And when I print it, it shows me the strings inside the tuple. And can it be reassigned? As we can see here, PORG. So from this, we can print it, but we can reassign it with string from the first. So first we start with integer here, and we can update that container with the different data type. Sure, you can do that. So the only way that you can change tuple is to reassign the container itself. Once you assign it, the way that you can change the individual element is if those elements is in a list within a tuple, like these right here. And the last part of week 2 lecture, and the last part of this portion of the lecture also is dictionary. And the way Python uses multi-dimensional lists outside of 2 dimensions. So if you have anything more than 2 dimensions, it's better to use the dictionary. And dictionary is an unordered collection of items. And each of the items in the dictionary has a key and a value pair. And this is very important to make notes of, because it relies on the key and the value pair in order to identify which field that is. And it's an optimized way for us to really retrieve the value referring to the key. So the way that we know it's a dictionary is it uses the curly braces, and each of the item is separated by the comma. So the way that we express this is it's going to be what key it is and what value you assign it. Now the keys can be used either inside the square brackets, or the way that we retrieve it, we can use the get method. This is a built-in method to be able to retrieve the key for the dictionary. So let's take a look at the example for the dictionary. So I have declare dictionary called my dict, and this is my key is name, and the value for that, the key name is Jack. The key here is H, and the value is 26. So if I wanted to output Jack, I would simply use the key, which is name, right here. And you can use different type. So often you would see string being used here, as we wanted to identify and then also output something that we can see. So when I run this, so if I wanted to output Jack, I simply bring down the key and keep it in the square bracket. Then if I wanted to output 26, which is the value for the key H, again, I can use the square bracket, or I can print using the get method. So I simply use get and then the key. So that's how I can output 26 here. Now, since I didn't have any key as address, when I try to get address, it's going to tell me none because it doesn't exist. So if you're trying to retrieve value for a key that doesn't exist in a dictionary, the interpreter will say none because it's not there for it to find. Now, if you want to update the value, you simply use the dictionary name, the key, and assign it a value. So as you update the H to 27, we can see here when we print, it shows that it is updated as a dictionary. The entire dictionary is what we printed here. So it shows that, the entire dictionary. Now, if we want to add an item, we simply state the dictionary, the key, and the value. So we add address downtown. And we print it again. Now, if we wanted to remove a certain key, such as address, then we can pop and then put in that key. So once we pop, it gets rid of the key and its correlated value. So it is now just name and age. Now, if we wanted to pop again, pop the last item, which is age and the age and its value. If we do a pop item with no parameter, we simply just get rid of the last key and its value. And similar to what you've seen, using the clear method, clear simply leave you with an empty dictionary. So you can use clear to clear out the dictionary. It becomes empty at that point. So that kind of shows you how you can use some of the built-in method with the dictionary, such as pop item, clear. Also how to use the value or the key to obtain the value. Also using get method, how to update value for a certain key, and how to add a certain item to the dictionary. And for the dictionary notes, that will be the last part of our notes, page 23 going into page 24. And on page 24, it gives you additional built-in methods outside of the example I showed. There are times that you might need to, look at the keys, return the dictionary keys, a list of the keys. You can do comparison. You can use the values method. So there are additional methods you can check out to be able to use the dictionary. Now on the last part, when you use the dictionary, as it is a container that contains groups of items or elements, we want to use the dictionary comprehension from an iterable in Python. So what does that mean? We have to take a look at how the key and the value is paired, and how it can contain the way that we would do the comprehension is using for or if statements. So here shows you the example on how to use the for to be able to obtain, to iterate through that container and access the key and its correlated value, which is called dictionary comprehension. So the example of this is I have a dictionary declared as squares, and I have the key as x. Its value is x times x. So we would have a for loop for x in range 6, print squares. So when we run this, we would start at 0, 0, 0, 1 is 1, and so forth. So when it goes 2, because 2 times 2 is going to give us 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. And it stops there because it reaches up to 6. So with this for loop, what we can do is we can print out a dictionary that shows us the value as squares. So when we square up x is x times x, and we print the squares. So this is a simple example of how you can use dictionary comprehension in your Python program, and in this case we're using a for loop, and simply for our variable, which refers to the key in the range and where you go, what value you want to go up to as key, and be able to implement that to print out the square value from 0 to 5, which gives you a total of 6 items. And so dictionary comprehension is on page 24. You can look that over, test the program so you can see further on how it works, understand the statement. And this concludes my lecture for week 2 in CIS30A, as we cover all 4 parts. So if you haven't watched the other videos, please go back and watch the other videos, part 1, 2, and 3. And thank you very much for your time to watch the video.